In the following video, let's ask the question, to find the transfer function of the following mechanical system with a force input Fn and an output X out. So the transfer function is going to be in the form X of S, X out of S over Fn of S. That's the transfer function we want. So let's go ahead and transfer this into a circuit diagram. Springs have impedance 1 over K. Mass has impedance 1 over ms squared. Forces are represented as current sources. And our nodes are going to be our displacement. So our x1 of s and our x out of x. So I'm identifying a node right here, x1. This is x equals 0, so that's ground. Note that masses are always connected to ground as well. So let's go ahead and see what we can do here. So we'll draw out our nodes. We have x1 here. We have x2 here, or let's say x out. We have a ground node. Mass is going to be connected to that ground node, so 1 over ms squared can be connected to ground. We have a spring here, K, connected between x in and or x1 and x out. So let's go ahead and add in an impedance here. That's 1 over K. And then we have 1 connected from x1 to ground. That's another spring, 1 over K, connected to ground. And then we need to add the source for this. We have a source here, Fn. So we're forcing the system connecting to x out right here, this node here. And we have a current source. We'll draw the current source going from ground through the circuit. So here we have Fn of S. So now pretty much everything is in the S domain, and we simply need to apply some circuits laws. So let's see what we can do here. I'm noticing right away that these two are in series. And let's ask ourselves first what we're trying to find. Let's go ahead and find X out of S. So that's that voltage drop from this node down to ground. So X out is right here. So what we can do is we can go ahead and find a current divider to see the current going through this branch and the current going through this branch. And the current going through this branch multiplied by this impedance will give us the voltage, or the displacement in this case. So let's take a look at that. If we go ahead and add these two in series, we get 1 over K plus 1 over K equals 2 over K, and the circuit becomes 2 over K in parallel with 1 over ms squared. And we have this current source here, Fn of S. Now, if we apply a current divider, what's the current going here? That's going to be, let's call that I mass of S. That current's actually going to be represented as a force, so F mass, and that's going to be equal to the branch we don't want, so 2 over K, over the branch that we do want, which is or the other two impedances, so 2 over K and 1 over ms squared. And that's going to be multiplied by Fn of S. And then if we multiply that whole thing by the impedance of the mass, 1 over ms squared, because remember we're finding this voltage from here to here, X out. Multiply that whole thing by this. So I duplicate this. Multiply these two together. This equals X out of S, and we're asked to find the transfer function. So X out of S over Fn of S is the transfer function. That's going to be equal to 2 over K times 1 over ms squared over, these two are added, 2 over k plus 1 over ms squared. And what we can do is simplify this into 2 over kms squared multiplied by 2 over k plus 1 over ms squared. Multiplying that through, we get 2 over 2ms squared plus k. And that's equal to our transfer function. So our final answer is 2 over 2ms squared plus k. Cool.